The thin, rocky outer layer of Earth above the mantle is called the crust. The crust is the hard outer shell of the Earth where we live. Imagine you're holding a chocolate truffle with its delicate shell and rich filling inside. The Earth's crust is much like that thin chocolate shell. It's the outermost layer that encases the entire planet. Just as the shell is the first thing you touch when you pick up the truffle, the crust is the outer layer we stand on, covering the much thicker and denser filling, which in Earth's case is the mantle. Just as the chocolate shell encases and protects the filling, the Earth's crust serves as a protective layer over the molten and dynamic mantle beneath. The process in which rock is worn away and transported by water, wind, or ice is erosion. Erosion is when natural forces move bits of rock or soil from one place to another. Imagine trying to keep a sandcastle intact on a busy beach as waves continuously wash over it and other beachgoers walk by. Just as the relentless movement of water and footsteps gradually dismantles and disperses the sand, erosion involves the gradual wearing away and transportation of rock by natural forces like water, wind, or ice. In both scenarios, whether it's the sandcastle on the beach or the rock in nature, the constant action of external forces breaks down and carries away material bit by bit, altering the original structure over time. The processes which break down rocks. Weathering. Weathering is the process where rocks are broken down into smaller pieces by natural forces like wind, water, and temperature changes. Imagine trying to untangle a pair of headphones that have been jumbled up in your pocket for days. Just as those small, repeated movements slowly knot and wear down the cords, weathering involves the gradual breakdown of rocks through repeated natural forces. The tangled headphones and the rock both undergo processes that change their structure over time, whether it's the friction and tension of the cords or the wind, water, and temperature changes acting on the rock. The central part of the Earth, below the mantle, is the core. The core is the innermost layer of Earth, made mostly of iron and nickel, and it's responsible for generating our planet's magnetic field. Imagine trying to find the source of warmth in a cozy, heated room on a cold winter day. Just like the heater is hidden away but essential for keeping the room warm, the Earth's core is hidden beneath layers but is crucial for the planet's heat. The heater in the room is analogous to the Earth's core, as both are central sources of heat that influence their surrounding environments, even though they are not directly visible. A sudden shaking of rock in the Earth's crust. Earthquake. It is the release of energy in the Earth's crust that causes the ground to shake. Imagine the frustration of a traffic jam caused by a stalled car on a busy highway. Just as cars are lined up bumper to bumper, waiting for the blockage to clear, stress builds up in the Earth's crust as tectonic plates press against each other. When the car is finally moved, traffic surges forward, much like how the sudden release of built-up stress in the Earth's crust causes the ground to shake during an earthquake. In both scenarios, tension builds up due to an obstruction, and when released, there's a rapid movement that follows, be it cars surging forward or rocks shifting along a fault line. The point directly above the focus of an earthquake, on Earth's surface, is the epicenter. The epicenter is the spot on the Earth's surface right above where an earthquake starts underground. Imagine you're at a crowded party, and someone spills a drink in the middle of the room. The immediate splash and wetness are felt at the center, but soon, everyone around the spill starts feeling the effects as the liquid spreads. Similar to this, when an earthquake occurs, the initial spill or disturbance happens deep underground, called the focus. But the impact is first felt at the epicenter directly above it on the surface, just like how the splash's effects first reach those closest to the spill. In this analogy, The center of the spill is like the earthquake's focus, and the point on the floor where the spill is most intense, directly above the center of the spill, represents the epicenter on Earth's surface. A break in Earth's crust along which rocks move, fault. A fault is a crack in Earth's surface where sections of rock can slide past each other, causing earthquakes. Imagine walking on a sidewalk when you suddenly come across a crack where the two sides have shifted slightly apart. Just like this crack disrupts the smooth path you intended to walk on, a fault is a break in Earth's crust where sections of rock have moved relative to each other. In both cases, the crack represents a division where shifts have occurred. On the sidewalk, it's the concrete slabs moving apart, while in Earth's crust, it's the movement of rocks along the fault line. The underground point where an earthquake starts. Focus. The focus is the exact location beneath the Earth's surface where the earthquake begins. Imagine you're trying to find the source of a mysterious noise in your house. Just as you might trace that noise back to a hidden spot, perhaps under the floorboards or within the walls, scientists pinpoint the origin of an earthquake beneath the Earth's surface. This underground starting point, known as the earthquake's focus, is like the hidden source of the noise, where the initial rupture occurs, sending vibrations through the ground just as a sound would ripple through your home. The rigid outer layer of Earth made up of the crust and upper mantle. Lithosphere. The lithosphere is the solid, outer part of Earth that includes the crust and the uppermost mantle. Imagine trying to open a stubborn jar lid that just won't budge. Much like that jar lid, the lithosphere is the Earth's rigid outer layer, composed of the crust and upper mantle, resisting change and movement. Just as the jar lid forms a protective barrier for the contents inside, the lithosphere acts as a protective shell for the molten layers beneath, with the crust being the lid's top surface, and the upper mantle acting as the twisting threads that hold everything firmly in place. Molten rock beneath the Earth's surface, magma. Magma is hot, liquid rock found beneath the Earth's crust. Imagine you have a pot of soup simmering on the stove, with bubbles occasionally breaking the surface. This bubbling soup is like magma, which is molten rock simmering beneath the Earth's surface, occasionally making its way to the top. Just as the soup bubbles up because of the heat from the stove, magma rises due to intense heat and pressure from the Earth's interior, waiting for any opportunity to escape, much like the soup bubbles waiting for a gap in the surface to release steam. The layer of rock between Earth's crust and core. Mantle. The mantle is a thick layer of rock inside Earth that moves slowly and affects how continents and oceans are shaped. Imagine you're trying to find that perfect middle layer in a sandwich that holds everything together without overwhelming the taste. Just like that crucial sandwich layer, the Earth's mantle is the intermediary between the crust, the bread, and the core, the filling, providing structure and support. The mantle, much like the sandwich's middle layer, ensures that the components above and below it stay in balance, maintaining stability and cohesion for the whole structure. One of the large sections of crust and upper mantle that fit together and cover the Earth. Plate. In simple terms, a plate is a huge moving slab of rock that makes up the Earth's surface. Imagine trying to assemble a jigsaw puzzle where each piece is unique in shape and size, but together they form a complete picture. This is similar to how the Earth's plates, which are large sections of the crust and upper mantle, fit together to cover the planet's surface. Just like each puzzle piece needs to fit just right with its neighbors to complete the picture, each tectonic plate must align with the others to form the Earth's crust. with their interactions causing phenomena like earthquakes and volcanic activity. The theory that Earth's crust is made of moving plates, plate tectonics. It's the idea that Earth's surface is divided into large pieces that float and move on the molten layer beneath them. Imagine you're trying to fit a jigsaw puzzle together, but the pieces keep shifting slightly as you work. This is similar to how Earth's crust behaves, made up of large plates that are constantly moving and interacting with each other. Just like the puzzle pieces that don't stay in place, the plates of the Earth's crust are in constant motion, driven by forces beneath the surface, causing them to collide, pull apart, or slide past one another, much like how your jigsaw pieces might overlap or separate on the table. A large mass of slow-moving ice and snow, glacier. A glacier is a huge, slow-moving river of ice and snow formed from compacted snow over many years. Imagine trying to move a heavy piece of furniture across a carpeted room. Just like how you slowly push and slide the furniture inch by inch, a glacier moves in a similar manner across the land, but at a much larger scale. The glacier is like that piece of furniture. It's a massive body of ice and snow that gradually shifts its position over time due to gravity, carving out landscapes beneath it, just as the furniture might leave tracks or indentations in the carpet. Molten rock that reaches the Earth's surface. Lava. Lava is hot liquid rock that flows out of a volcano during an eruption. Imagine a pot of soup on the stove, simmering gently, and as it heats up, bubbles start to rise and occasionally spill over the edge. This is similar to how lava behaves, as it is molten rock that rises from deep within the earth and spills out when it reaches the surface. Just like the soup bubbling over due to heat, magma within the earth is heated and forced upward until it escapes as lava, overflowing like that soup from the pot and spreading across the surface. A mountain through which lava flows to Earth's surface. Volcano. A volcano is an opening in Earth's crust that allows molten rock, gases, and ash to escape. Imagine you're trying to unclog a stubborn kitchen sink drain that's backed up with water. Just like the pressure builds up in the pipes until the blockage is cleared and the water flows out, a volcano is a mountain where pressure builds up from molten rock beneath the Earth's surface until it erupts as lava. In this analogy, the clogged drain is like the Earth's crust. The backed up water represents the molten rock, or magma, and the eventual flow of water simulates the lava flowing out of the volcano. The layer of gases that surround the Earth, atmosphere. The atmosphere is a mix of gases like oxygen and nitrogen that surrounds our planet, protecting life and helping regulate temperature. Imagine trying to keep your house warm during a chilly winter's day. Just like how your home's walls and roof trap warmth inside, the Earth's atmosphere acts as an insulating blanket, keeping our planet at a stable temperature. The layers of gases surrounding the Earth, much like the layers of insulation in your home, prevent essential heat from escaping into space, ensuring a livable environment for all life forms. All the water on Earth. Hydrosphere. The hydrosphere includes all the water on Earth's surface, underground, and in the atmosphere. Imagine trying to find your keys in a messy room where everything is scattered around. This scenario is similar to understanding the hydrosphere, which involves all the water on Earth spread across various places like oceans, rivers, glaciers, and even underground. Just as you need to consider every corner of the room to locate your keys, the hydrosphere requires us to consider every nook and cranny of Earth where water might be found, demonstrating the interconnectedness and vastness of Earth's water systems. The process of dropping sediment by water or wind. Deposition. It is when particles carried by wind or water settle and accumulate in a new location. Imagine coming home with your hands full of groceries, and as you walk through the door, you automatically drop the bags on the counter. This is similar to how water or wind, after carrying sediment over a distance, comes to a stop and drops it in a new location. Just like you naturally deposit your groceries at a convenient spot when you no longer need to carry them, wind and water deposit sediment when they lose energy or the conditions change, leaving behind the materials they were transporting.